All right, now we're looking at example 3. We're going to use the remainder theorem, which is listed at the top, to evaluate a polynomial function. So the remainder theorem says that if p of x, our function, is divided by x minus c, then the remainder equals p of c. So let's just see what that means, and I'll refer back to the remainder theorem as we work through this. So first off, let's divide by x minus c. So let's see here. We have two different c values. We have c equals -2. And so what we want to do is we want to use the remainder theorem. It says to do that to find p of c. So the remainder theorem says that we need to divide it by x minus c. So let's do that. So what we want to do, okay, so thinking about what we did on the previous video with the synthetic division, what this is saying, if you think about it, it subtracts c, and that's how synthetic division works. We want to use the opposite sign. If we want to divide by x minus c, and using synthetic division, we would want a -2 up on top, and then we would want to take the coefficients from p of x. So that would be 2, 3, 2, and -2. And we see that it goes cubed, square, x, constant. So we're not skipping any terms. So there's no zeros that we need in this one. All right, so we bring down the 2. -2 times 2 is -4. 3 plus -4 is -1. -2 plus -1 is, times -1 is +2. 2 plus 2 is 4, and -2 times 4 is -8, and -2 plus -8 is -10. Okay, so notice that it says then the remainder equals the remainder. So this is our remainder, -10. So the remainder equals p of c. Okay, so notice that it says use the remainder theorem to find p of c. In this case, we have c equals -2. So if we find p of -2, that's what it's asking us to find. It says find p of c. So in that case, p of -2 is equal to the remainder. The remainder equals p of c. So our remainder is -10. There we go. That's what we've just determined. We've used the remainder theorem. It's a pretty interesting theorem. It's not that intuitive that this would happen. That if we divide by x minus c using the synthetic division, we end up getting -10 as a remainder, which is what p of -2 is equal to. It's actually pretty interesting. So anyways, that's our result. Let's do it again with c equals 1/2. So c equals 1/2. So what this is saying is we're going to put 1/2 up here, and we're going to use the same values: 2, 3, 2, -2, because that's our numerator, because we're dividing p of x by x minus 1/2 in this case. Okay, so we want to take 2, bring it down. 1/2 times 2 is 1. 3 plus 1 is 4. 1/2 times 4 is 2. 2 plus 2 is 4. 1/2 times 4 is 2. And that then gives us -2 plus 2 is 0. Okay, so our remainder, we actually do not have a remainder. Our remainder is 0. So that tells us p of 1/2 is equal to 0. Okay, so hopefully that makes sense. We use synthetic division, and we determine what the remainder is, and that will help us determine what our evaluating at that value, in this case, -2 and 1/2. If we evaluate the function at those values, what the solution will be. And yeah, so let me know if you have any concerns about this procedure. I'll be more than happy to help. And you can also check your work by just plugging the value directly in. We could just plug in -2 into this function and just plug it all in, and see what we get. But hopefully this makes sense. Let me know if you have any concerns. I'll be more than happy to help.